Hello viewers, welcome to EF. Today we are going to discuss about what is advanced IT security. Today we are going to discuss about complexity theory. So we will see what is problem, what is decision problem, algorithm and its property, what is decidable problem, what is decidable decision problem, and also the undecidable problem and practically solvable problem. Now let's see. So what is problem? Problem is a mapping from a set of input to a set of output. In this figure you can see we have input I and we have a P which is maps I to output 0. These are the example of problem. First one is sorting problem where we have input x1 to xn and all of x are belongs to natural number. We have output where we get a permutation such that x pi of I is equal to or smaller than x pi of I plus 1 and I is ranged from 1 to n. We have premilitary test problem where input is a natural number and we get output yes if n is a prime number, no otherwise. There is a problem called RSA inversion where we have input is equals to NEC which are natural number and n is equals to two prime numbers. N is equals to two multiple of two prime numbers p and q and we have the greatest common division of E and p minus 1 q minus 1 is equals to 1. Then we get the output depending on the input m which belongs to natural number with m to the power a is equals to the chosen c for mod n. We know about the factorization. In that case, we will have the input of n natural number and then we will get output of factorization of n into primes where we have pi to till pk natural numbers and p1 to pk natural numbers where pi is the prime numbers. I is ranged from 1 to k and E1 to till ek which belongs to natural number are the power of p. So pi to the power of ek is we can say p1 e1 multiply p2 e2 till pk ek is equals to n is the factorization of n number. Now what is decision problem? Decision problem is a problem where we have input in the input domain. For each input in the input domain, output is restricted to yes or no. Means for depending on the output, the input set is partitioned into two subsets. You can see in the figure that we have input and P is the mapping from I to yes or no output. It's called the decision problem. Before going to decidable decision problem, I would like to review again what is algorithm. And according to Knuth, algorithm consists of a finite set of number of instructions. The execution of an instruction is called steps. Now, algorithm consists of 5 properties. One is finiteness, which means that for every input, an algorithm always terminates after a finite number of steps. We have definiteness. Each step precisely defines action to be carried out are unambiguously specified. We have input, algorithm must have 0 to many input, and algorithm should contain output. Algorithm may have 1 to many output. What is effectiveness? Sufficiently basic instruction to be carried out exactly and in finite time. So these are the 5 properties of an algorithm. Now let's see what is decidable problem. Decidable problem means the problem which have an algorithm that would deterministically solve the problem in a finite number of steps, and the output is not restricted to yes or no. So the problem which has an algorithm is called decidable problem. Now there is another most important type of problem that is called decidable decision problem, where you have an algorithm that can deterministically solve the problem, and for each input in the input domain the output is restricted to yes or no. But the interesting part is here that the algorithm has a maximum running time for a given input size, and then compute the running time as a function of the size of the input. Means here for any input at the input domain the output is restricted to yes or no. However, we don't put any time constraints at the running time complexity of the algorithm, so the problem has no time restriction when it terminates. Now there is another type of problem that is called practically decidable decision problem. Out of numerous problems, only few are decidable, that is, decidable algorithmically. Again, among the decidable problems, the available solution is not efficient enough, and only a small fraction of them can be solvable in acceptable time and polynomial time. So, you can see in this picture that we have different kind of problems. The black circle inside of that there is a small subset is decision problem, which also contain different kinds of undecidable problem, halting problem, totality problem, equivalence problem, and also there are some problems which give output yes or no. Inside of that we have decidable decision problem like fat and many other problems. Instead of that blue color marking the practically decidable decision problem which can be solvable in practical time. Mm, Practical time. In later video I will discuss what it means, what is explained by the practical decidable problem. So be with us. Now I'd like to also tell you about what is undecidable problem. It is the problem which doesn't define any output and cannot be solved by algorithmically, and hence we can do something about this kind of problem. Example is halting problem, totality problem, and equivalence problem. Next video will contain about what is halting problem and explanation proof of how halting problem is undecidable and other problems. So stay with us. If you like the video, please subscribe, and I wish you will with me in the next video. Thank you for watching this video.